Hello students, welcoming you to my channel. Today we will study about the parallelogram. Okay, it is of class 8. So please follow me. Let us start. What is a parallelogram? It is a quadrilateral. Yes, it is a quadrilateral. So it is a quadrilateral whose opposite sides are parallel. So it is a quadrilateral whose opposite sides are parallel. So let us draw a parallelogram and you name it ABCD is a parallelogram. And it is a quadrilateral. And you see, if I ask you what are the elements of the parallelogram, you see parallelogram has 4 sides and 4 angles. So these are the elements of the parallelogram. And you see 4 sides, opposite sides, opposite angles, adjacent sides, and adjacent angles. These terms we use. You see, opposite sides. There are 2 pairs of opposite sides. You see here. AD is parallel to BC. AB is parallel to DC. So AD is parallel to BC. AB is parallel to DC. So this is about the opposite sides. And opposite angles, you see, this angle is opposite to this angle. So this is a pair, angle B and angle D are a pair of opposite angles, and angle A and angle C. This is a pair of opposite angles. Then come to adjacent sides. If you start from here, suppose BC. So BC is connected with CD and also with BA. So this line segment and this line segment, you may call it, these are 2 adjacent sides, or BC with CD, that is also a pair of adjacent sides. CD with AD, that is also pair of adjacent sides. Or AB with BC, like this, they are connected. These are adjacent sides. And what are adjacent angles? You see, angle B with angle A, this is a pair of adjacent angles. Angle B with angle C, this is also a pair of adjacent angles. For angle C, both angles B and D are the adjacent angles for the angle C. For angle D, angle C and angle A. For angle A, angle D and angle B. So you can call it like this. These are the adjacent angles. So these are about the elements of the parallelogram. Okay? So now we will know about the properties of the parallelogram. So we will know the properties of the parallelogram. You see, opposite sides of a parallelogram are of equal length. Number 2, opposite angles are of equal measure. Number 3, the diagonals bisect each other. Where? At the point of their intersection. At the point of their intersection. So these are the properties. These are the main properties we will have to discuss now. So point wise we will discuss. So follow me. You see, first we have to prove opposite sides are of equal length. Let us draw. A parallelogram. So A, B, C, D be the parallelogram. And we have to prove opposite sides are of equal length. So let us construct here the diagonal BD. So this diagonal divides the parallelogram into two triangles. You see here, one is ABD and the other one is BCD. There are two triangles. You can see here. And you see, they already have known that parallelogram is a quadrilateral whose opposite sides are parallel. So we will take one pair of the parallel sides. You see, AD is parallel to BC. AD is parallel to BC. And you see, BD is the transversal. BD is the transversal. Already you know that when two parallel lines are cut by a transversal, the alternate angles formed are equal in measure. And you see, AD and BC are parallel and BD is the transversal. So you see, this angle and this angle, they are equal in measure. Let us name them. Let us see. It is angle 1 and it is angle 2. And you can see here, AB is parallel to DC and BD is the transversal. Yes or no? So this angle and this angle, there are two alternate angles. So if I write here angle 3 and it should be angle 4. So already we have known this from the properties of the angles found by parallel lines and their transversal. Previously already I have done a video on it. You might see that. So you see, AD is parallel to BC and BD is the transversal, and angle 1 measures equally with angle 2. Like that, AB is parallel to DC and the same BD is the transversal, and angle 3 is equal to angle 4 in measurement. Okay? So both angle 3 and angle 4 measure equally. So here what we got? 8 is parallel to BC, and from this we got measure of angle 1 is equal to measure of angle 3, and now we got angle 3 is equal to angle 4. Same bit is the transversal, and AB and DC are parallel in this case. So you see, what we have to prove? Already you know this. So, to make you recall, just I wrote this. So how will you do this? You see, in between or in the triangles, ABD and BCD. ABD, this triangle, and BCD. What we have to prove? You see, angle 2 is equal to, or the measure of angle 2 is equal to measure of angle 1 due to alternate angles. And you see, BD, common arm, for ABD triangle, BD is present. It is one side, and the same side also remains in BCD triangle. So BD is the common arm. Then come to angle 4 is equal to angle 3. That means the measure of angle 4 is equal to the measure of angle 3. Both the angle 4 and 3, they measure equally. What is the region? You have to mention the region here. Alternate angles. So both the triangles are congruent. And what is the congruence condition? You see, ASA. Angle side angle, that is called that congruency condition. That means angle, two angles, and the included side is BD, and its two endpoints, two angles. You can see here. So we can write triangle ABD is congruent. You give the symbol like this. And you see, you have to follow, you have to maintain the order of the letters while we are doing the congruence of two triangles. So we have to maintain. You see, the vertex A. So here is the vertex A. Okay. So you see, so this point corresponds to this point, this vertex C. So for A, you write here C, and come to B. You come to B, and we are discussing about the triangle ABD. So ABD, this angle, angle 4, B is the vertex. It corresponds to which vertex of the BCD triangle? So angle 4 is equal to angle 3. So this is D, point D. So the point B, the vertex B of the triangle ABD, that corresponds to the vertex D of the triangle BCD. So you write D. So already you have written CD. So you can write now B, you see. How? Now again you see the vertex D for the angle ABD. So here is the angle is 2, and that is equal to angle 1 in measure. So angle 1, where it is? At the vertex B of the BCD triangle. So you have to maintain the order of the letters here, otherwise it will be wrong. So you have to follow this. So you have to mention here the congruence condition. AAC, angle side angle, congruency condition. ASA, congruency condition. So what happened? So now we can see here, opposite sides are of equal length. We can get. How? You see. Now we knew that angle A is equal to angle C. Yes or no? And also already we have known from the very beginning that angle 2 is equal to angle 1, angle 3 is equal to angle 4. So all these and these two triangles, ABD triangle ABD and triangle CDB, they became congruent to each other. And we have to find the opposite sides. That means, you see, AD is the opposite side of which angle? Angle 4. And angle 4 is equal to angle 3. So the opposite side of angle 3 is BC and the opposite side of angle 4 is AD. As angle 4 is equal to angle 3. So the opposite sides of both the angles will be equal to each other. That means they will be of equal length. So the opposite side of angle 4 in the ABD triangle is AD. That is equal to the opposite side of angle 3 is BC. So you see, both AD and BC are the opposite sides or not of a triangle. So we prove that the opposite sides are of equal length. So like that, we can also show here, you see, the length of AB is equal to length of DC. How? You can see here, angle 2 is equal to angle 1 and both are congruent. So the opposite side of angle 2 in the triangle ABD, that is AB, that is equal to opposite side of angle 1 in BCD triangle. You see, this is the opposite side CD or DC of angle 1. So AB is equal to DC. Here you see, the opposite sides are of equal length. So you should understand this and you should practice at home. If you do not practice it, you cannot know this properly. And if you have to remember, then in mathematics you have to work out. So you practice more and more, then it will be better for you. So now we can prove. So first one is over. The opposite angles are of equal measure. So you can see here, already we have discussed it. AD is parallel to BC and BD is the transversal. So here you can see angle 1 and angle 2 are two alternate angles and they are of equal measure. So you can see here angle 1 is equal to angle 2. What is the region? Alternate angles. already we are now just proving the point 2, alternate angles. And you see angle 4 or angle 3, it is equal to angle 4. So we may write like this: angle 4 measures equally with angle 3 due to alternate angles. Just on adding, what happens? Angle 1, measure of angle 1 plus measure of angle 4 is equal to measure of angle 2 plus measure of angle 3. And you can see here 1 plus 4, that means this angle B. So that implies angle B. The measure of angle B is equal to measure of angle D. So you could see that opposite angles are of equal measure. You see both angle B and angle D are of equal measure. So we could prove this. And we have to prove now that angle A measures equally to angle C. We have to prove this. But these are also opposite angles in the parallelogram. This is also one pair of opposite angles. So you see this for the angle B and angle D, how they are equal in measure because both are the opposite angles. So now we will prove. So you see in between triangles ABD and BCD. ABD and BCD, in between two triangles. What we have to mark here? Whether they are congruent or not. If they are congruent, then our matter is solved. You see. So for ABD triangle, you see angle 4 is equal to angle 3. Already we have proved this. To prove this, already we have proved alternate angles, because you see AB and DC are parallel and this is the transversal. So these alternate angles are of equal measure. So angle 4 measures equal to angle 3. Then you see BD, common arm, and angle 2, because as we have written ABD triangle first, so we will start the information from that angle. So angle 2 that goes to ABD angle. So angle 2 measures equal with angle 1 of BCD triangle. So alternate angles. So triangle ABD is congruent to triangle. So we have to follow the order of the letters. You see A, it will correspond to vertex C of ACD. And you see the vertex B of ABD, the vertex B of ABD, at B the angle is 4 and which is equal to angle 3. So angle 3 is at vertex D. So we will write here D. So the vertex B of ABD triangle, that will correspond to vertex D of the second triangle. And D, ABD. So angle 2 that is equal to angle 1. Where it is? It is at vertex B of BCD triangle. So CTB. So this is ASA, angle side angle, congruence condition. So what we got? Now as you see, BD is the common arm. BD is present in both the triangles, both in ABD and BCD. And what we have known, now after they have become the congruent triangles, you see, suppose one side corresponds to other side, other triangle, okay? So, their opposite angles are equal in nature. So, in ABD triangle, the BD side has the opposite angle, angle A. That is equal to the same BD side. It has the opposite angle and angle C in case of BCD triangle. So you see, both angle A and angle C are opposite angles, but they became equal in measure. What we proved? So the point 2 is over. Now we have to prove the diagonals bisect each other at the point of their intersection. Just we will have to prove that. So I will name it A, B, C, D, 4 vertices. This is a parallelogram, and you draw its two diagonals. Let the point of intersection, this point, you name it as O. And what we will have to prove? That the diagonals bisect each other. That means you see AO is equal to CO and BO is equal to BO. We have to prove. Okay? So now we will have to consider, you see, either you take this triangle between these two triangles or these two triangles. It will be better for you from your base side to take this triangle and this triangle. Okay? Both are congruent or not, we will have to prove. Already we know that the length AD is equal to the length BC. Like the length AB is equal to length BC. Because parallelogram is a quadrilateral whose opposite sides are of parallel and they are equal in length. So we have to prove what? In between triangles AOD and BOC. Because you see, in both these triangles, these line segments are present. AO, CO, BO, DO or OD. These sides, what we will have to prove, are present in two triangles. So we have to make them congruent. Further we will see whether they are congruent or not. If they are congruent, then matter is over. And you see here, AD is parallel to BC. BD is the transversal. Yes or no? So, this angle is equal to this angle. Let the angle be 1 and let this angle be 2. And you see, this line segment, these two opposite sides are parallel and AC is the transversal. So what we got here? This angle measures equally with this angle. Let it be angle 3 and this will be angle, let it be angle 4. So you can see here angle, side, angle. That means two angles and one included side of one triangle are respectively equal to the two angles and one side of the other triangle. That means of the BOC triangle. So here you see between AOD triangle and BOC triangle. What happens? You see here. So we will write the information of AOD triangle first because we have mentioned the triangle AOD here. So angle 1 measures equal with angle 2. Why? Now this is the transversal and two parallel lines are cut. Here you see BD is the transversal and AD is parallel to BC. So alternate angles. Alternate angles. So AD, the length of AD is equal to length of BC. Because in case of the parallelogram, already you know that the opposite sides are of equal length. It is one of the properties. And come to angle 3 is equal to angle 4. What? The same alternate angles. So what happens? That these two triangles became congruent. So how we have to write? We have to follow the order of the letters. AOD is congruent to triangle. Then come here. Let us follow the corresponding letters. You see the vertex A of triangle AOD. Which angle is here? Angle 3. That measures equally with angle 4 and angle 4 is at the vertex C. So we have to write here C. So the vertex A corresponds to vertex C. Then come to point O. So this point O. Okay. So this is the common point for both. You see here. So write O here. And for the vertex B of AOD triangle, AOD. So here angle 1 is present. Angle 1 is equal to angle 2. And at angle 2 is at vertex B of BOC triangle. So we have to write here COB. So what is the congruence condition here? Angle, side, angle. A is a congruency condition. So what we got? For the corresponding angles, you see these became two congruent triangles. Angle 1 of one triangle is equal to angle 2 of the other triangle. Angle 3 of one triangle is equal to angle 4 of the other triangle. So their opposite sides are equal respectively. You see angle 1, the opposite side of angle 1 is AO. That is equal to angle 1, the opposite side is AO of angle 1. Angle 1 is equal to angle 2. So the opposite side of angle 2 in BOC triangle is CO. So we first proved it or not? This part is over. And you may see angle 3 which is equal to angle 4. After congruence we are deciding here. The opposite side of angle 3 in the triangle AOD, that is DO. Because already we have taken the first triangle AOD. Then the next triangle you see BOC. So angle 3 is equal to angle 4 and angle 4. It has the opposite side BO. So DO is equal to BO. So it is better if you can write after congruency condition what we got the outcome here. You may write here by CP/CT. This is also by CP/CT. It will be better if you do this. So it is solved now that the diagonals of a parallelogram, they bisect each other at the point of intersection. So after the congruency condition, when the two triangles became congruent to each other, we got this result we could prove. But I wrote here by CP/CT. By CP/CT, that means CP/CT. Congruence properties of congruent triangles. This is the capital C. So C stands for congruence, P for properties, C for congruent, T. This is the adjective. It's congruent triangles. So this is the full form. So after the congruence of triangles, what result we got, we could prove. You can write by CP/CT. So this is all about what we studied. Just we studied about the parallelogram, what it is, and the elements of the parallelogram, and also the properties we discussed. And in the next class, just we will do the solution, that is 3.3 exercise. I will send you. So wish you all the best. If you have not subscribed the channel, please subscribe the channel.